Hello, everybody. I'm Ash Davies. I'm an Android developer here in Berlin, also a Google Developer Expert, and I'm here to talk to you today about the navigation components and my experience with it and how I was skeptical at first of using Fragments, but it sort of grew on me. Or am I talking about cheese? So a few of you might remember from yesterday that during the random slides, we had a few very unfriendly topics, and the person who suggests this knows who they are, and thank you very much for making my life very difficult. But let's probably stick to something I'm a bit better with. So, navigation, or particularly the navigation library. What is it trying to solve? Well, navigation. So, navigation is hard, and it might sound like a bit counterintuitive to start off a talk about navigation by just saying, well, this is hard, because development is hard. But it's often a point of confusion for new developers, because navigating from screen to screen is such a fundamental part of building your application. So why is it so confusing if it should be so simple? Well, it started off with activities. Activities are a system-level component in Android, much like content providers, services, and broadcast receivers. In the simplest form, you can just use an intent to move from one activity to the next. And here you can just see you're encoding the parameter on the intent to pass to the next activity. But in this instance, the calling activity knows the name of the intent from the receiving activity, and the receiving activity also has to deserialize this. So you can understand why this can quickly get out of hand if you're getting into larger projects. So this can be quite difficult. So because these activities are depending on the other activity implementation, the storing intent, argument compositions, and navigation can be quite difficult to maintain. So let's think back to 2016, and before we had any of this Jetpack stuff, and we had this quote from Diane Hagborn. Now this is back when Google Plus was still a thing, but it was sort of a controversial quote, because as developers, we're looking for guidance, we're looking for some kind of direction on these different things, and then to have this quote saying, well, essentially, we don't care. Now, that's true. The framework shouldn't care. The framework shouldn't really be opinionated on how you architect your application, but you should care a lot. So once the activity is started, it's up to you to handle how you flow. Now, Honeycomb breaks the screens up into fragments with the introduction of fragments in API level 14, and it would allow you to build richer and more interactive user interfaces. And this is sort of the beginning of design-oriented thinking for Google and Android. You'll probably recognize this when it was implemented in the master detail interface, in the Contacts app, and I think more recently in the Gmail app. You'll have responsive layouts for larger screens, and it should also run properly on smaller screen devices. Should. So this is a sample on how to implement fragments in Android. This is from the documentation page. As you can see, it's not Kotlin, and it's not pretty. But it's effective. It does the job. You can see the fragment transaction going on here with the fragment manager, beginning and adding the transaction. This adds it to the backstack and does everything necessary. It's a bit more complex than just starting an activity, just creating an intent and starting that off. And you have to handle some difference in behavior. So for example, the state of the activity would then stipulate how you should react. So if your activity has been recreated from configuration change or from orientation change, then you won't want to add that fragment because it's got its own lifecycle to deal with. So otherwise you'll have nested or overlapping fragments. So you're already adding conditional statements to the very fundamental basis of what's going on. So this quickly does not scale. And let's add to the fact that the activity lifecycle does not equal the fragment lifecycle. There's lots of different little nuances that kind of trip people up as well. And let's add to that as well, neither do those equal the view lifecycle. The view has a lifecycle. It's a thing. So you can see from this diagram from Jose, the differences in fragments and activity behavior and how they interact with each other. The URL is available in the slides, which I'll share at the end. But you can see like how the activity interacts with a fragment normally and how it retains with a fragment whether it's non-retained or detached. And this is a bit kind of confusing to follow, and it's a bit difficult to know as a beginning developer, or even as a senior developer. I forget these all the time. So not only that, you have to manage your own backstack. So you have to explicitly invoke add to backstack if you're not using add, and you can mess things up really easily if you're not doing it properly. And it's very easily to not do it properly. So you'll have invalid stack, unexpected behavior on configuration. As I mentioned, if you're not checking for the saved instance states, then you'll end up with overlapping fragments. You then add dialog fragments on top of that. So it's a bit tricky. Then you've got the support fragment manager and the child fragment manager, and which one should you use? Should you use the child fragment manager inside a fragment? I mean, spoiler, this is actually mostly meant for having fragments inside of fragments that don't affect your fragment backstack. You can understand why it's a bit confusing. And add to that, it's difficult to actually communicate between fragments. You have to communicate via the activity. Remember when we would only use a dialog fragment, you'd have to then cast the activity to the implementation of an interface on attachment. And you would not guarantee that your activity would actually be implementing this, and you could have a class cast exception, or if you didn't check for it, of course. But it was kind of highly coupled with the implementation, and you don't want to have that. You want to have detached, decoupled implementations. And again, bundles, our lovable bundle of joy. This is how we serialize data going between activities. It's also how we serialize going between fragments, because we can't instantiate fragments ourselves, because we have to let the system do this, because we have the fragment lifecycle. So we have to tell the system on how to encode and serialize our data that we need for the fragment to actually start properly. So because of this, like activities, you can't use fragment constructors until we have Fragment Factory, that is. This is available in the beta at the moment. This allows you to register a Fragment Factory with the support Fragment Manager to then tell the system how you want to build your fragments. This is very similar to the view model provider.factory interface. You can use it with Dagger to inject dependencies into your fragments so that you're using a constructor injection instead of something like Dagger fragment, which uses post-instantiation correction. Injection. So these are all some pretty damning reasons not to use fragments. And with all these compelling reasons, would you think, I'm going to walk away from this thinking I should use fragments? I can understand why you wouldn't. And it's really tempting to use pure activities in your flow and only activities. And there's a lot of other developers who have thought of kind of new and wonderful ways to solve this problem by having custom views, custom implementations, if we all remember Mortar and Flow. So there's lots of different types of things for this. So we're obviously trying to solve this problem, but let's take another look at fragments. So there may be some good reasons to use fragments. So bear with me on this one. You might need some convincing. So with activities, they're part of the framework, which means every time there's a new feature or something new introduced into the activity, it's part of the API. And it means you'll have to wait sometimes a couple of years to actually gain access to that new feature. So this means that they have to be backported in compat. So they have compat, activity compat, and all these different backported things. But they're not really backported because you can't backport them. You can only provide compatibility. So on older versions, they just don't work the same way. And you can't guarantee that behavior. An example of this is the shared element transition. So you can see here how the element transitions from one screen to the next. Now, this is only available on API 21 and above. And compat shims, like Activity Compat, only provide us with failure-saving API checks to make sure that it fails gracefully instead of crashing. But it doesn't implement the same behavior on previous APIs. You don't get that. So not only with that, you'll get actually some strange behavior, some erratic view behavior, and sort of it makes us think that compat shims aren't enough. So when you compare that to what we have with fragments, now in API 28, fragments have been fully deprecated, framework fragments that is, and we're now using the Android X fragment. Now this is great because the Android X fragment is shipped quite frequently, and we don't have to wait until the API actually allows us to use these features because these are actually already available in this library. You're using a library, not the framework. So it means we can update much faster. And one of the nicest things about this is actually scoping. Now, a lot of us have had this problem before when you've wanted to share data between several activities, and it might be only relevant for a few screens. It could be like a cache of user data or a repository or a client you only need for a short amount of time, but you don't need it for the entire application, you just need it for 3 or 4 activities. There's nothing that lives between an application and an activity that allows us to store that data. So we'd end up putting these resources into our application scope, often being quite expensive and affecting the overall performance of our application. So by using fragments as a sort of destination or original screen, then that lets us use activities as that mid-level operation. So consider this, where you have 2 activities. Sharing resources, as I mentioned, you have to use in the application. Using fragments, you can now store resources in an activity which can span the scope of several fragments. And now we have view models. We can use this with a shared view model between the 2 screens. So with these benefits and these drawbacks, it might be thinking, well, it sounds good, but I'm not enticed. So how can we have all these benefits, but then not have to deal with the drawbacks? How can we have our cake and eat it, as a lot of British people like to say? Cheese. You thought I was done with cheese? No. Sorry, that's finished. So last year, Google introduced us to Android Jetpack, which is a variety of tools to sort of bootstrap Android development. It provided opinionated and clean implementations for a lot of basic problems that allowed us to compartmentalize all these different libraries and all these different implementations, and it also served to rename the support dependencies from app compat to Android X and start over with the independent versioning, so we can use these libraries independently and a little bit more reliably. The components of these were the foundation, This includes the KTX helpers, the multi-dex, and the security, and you've got the architecture components like live data, view model, navigation, which I'm going to go into now, and paging and room persistence. You have behavioral components like media playback, notifications, permissions, slices, and finally UI, which is the fragment transitions, fragment behaviors, fragment animations, emojis, view animations, and the likes, and also fragment KTX helpers. So let's go into Jetpack navigation. What is navigation, or navigation component? So simply put, it's a set of libraries and a plugin and tooling for unifying and simplifying Android navigation. It handles all the common parts of navigation patterns, and it's easily handling patterns like drawers and bottom navigation. So you've got fragment transactions being handled, you've got the up and back actions being handled correctly, the standardization of transition resources, deep link implementations. I'll go into this in more detail, but it's absolutely amazing. Navigation patterns are really easy to implement, and you have what's really, really useful, type-safe arguments, as I'll go into now, or shortly, sorry. So the nicest part, one of the nicest parts about the navigation component is that it implements correctly the principles of navigation. Now, the principles of navigation are a set of rules that you should adhere to make sure that you give your user a consistent user experience design with intuitive user interfaces. And the navigation library is designed to implement these principles by default. These principles being fixed start destination. So you should expect that the same flow has the same returning flow as well. So if you're coming from the activity icon in the drawer, you're going to end up going back to that same way by following the back button. Your state should be represented as a stack, which is a replayable list of histories that you can then transcend back through and replay as necessary. The up and back button should behave the same, with the exception of the up button never actually exiting your application. So this is often demonstrated when you are at the top level of your application, and you wouldn't have a back button or up button, sorry, because it wouldn't make sense. You would have perhaps just a toolbar title, or you'd have a navigation drawer icon or the hamburger icon as necessary. Another principle is that deep link simulates manual navigation. This is that if you are using a deep link from an external source, whether it be from web or otherwise, it should have the same stack as if you had actually navigated it manually. This means it has to be created artificially, and it'd be quite difficult to do so if you're using fragments manually. So it's really nice that navigation handles this for you. So the primary ideal of navigation isn't to kind of introduce APIs that are not accessible to you. It's not private or limited by library scope, and it's built using code that you could actually use yourself and build yourself. So all these APIs, you could perhaps just introduce another implementation. You could tweak it in ways that fit your application, because navigation is so intrinsic to your own core application and brand guidelines that you want to be able to change it as and when is needed. So as I mentioned, it's built from 3 components. So you've got the navigation graph. Now, in Android Studio 3.3, it introduced a new navigation editor, which is a graphical editor showing you your overall fragment graph, allowing you to edit it in a really kind of nice way. So you can see in the first panel on the left that you've got destinations showing your hierarchy. You can see at the top the activity main, which is the host, and each one of the screens underneath, which is our fragments, or can be implemented as you need. Destinations can be an activity, a fragment dialog, or a custom view. In the central screen, we've got the graph editor showing a visual representation of your graph. This is how the destinations navigate to each of your different areas, what arguments are necessary, if you have nested graphs. And it's really nice to show this visual implementation of your user experience navigating through your application. And on the third panel on the right, you can see the attributes for each of your destinations or each of your selected destination. These show the argument default values, the global actions, any deep links, the label, the identifier, and where your fragment is, your graph is starting. So as I mentioned, destination types can be of an activity, so you use the activity tag for this, a fragment, a dialog, which is introduced in 2.1 and above, so it's not yet in stable production versions, but if you want to use beta, you'll be able to access this. But the nicest thing about this is that you're not limited by these 3 different types. If you want to implement your own view, you can do so quite simply, actually. You just have to extend the navigator in your application with the type of your destination that you want to provide. You provide the destination implementation. This is a representation of your dialog fragment, of your custom view, and then you have your navigator then configure how it wants to navigate to that, and you assign the arguments after the inflation of your view. And then you have to add this navigator to your controller. So you have then your navigation graph. This is the XML representation of it. Now, if you're like me, you might like to actually hand code XML. The tool was built in such a way that the visual editor will actually produce readable code. Now, I know some of you are saying, XML again, no. We have to. It's layouts, it's resources, it's Android. But yeah, so it's quite straightforward to actually design something like this and actually add your activities and fragments and actions and arguments and everything that's necessary. But it is resource inflation. So this happens at the same time as your layout inflation. And because it's an XML document, this is actually inflated at runtime. So whilst compile time errors will still happen if you reference the wrong class type or if you have just some bad XML, if you reference perhaps the wrong direction in a different destination, then it will actually crash at runtime, which is something to be aware of. It doesn't happen that often, but it's something to be conscious of. And you have the nav host fragment. This is the host for everything else that's kind of moving all these kind of components around, and it's implemented kind of for you, which is quite nice. And then finally you have nav controller, which is how the manipulations happen, who's controlling all these different behaviors and how it's using on the nav host fragment is by extending this. So you can retrieve the nav controller from any of your common framework types, from the fragment, from the view, from the activity. You have to provide the actual resource ID if you're coming from the activity, because there can be, of course, a larger layout. The view and fragment retrieve it from their parent. And then you can use the controller to navigate to different parts of your application as specified in your navigation graph. It's recommended to use the navigation functions here on the controller. And then you can also create a navigation on-click listener to assign to buttons or, well, any views that have a listener for clicking listeners. So, as mentioned, we've also got deep links. Now, the navigation component can generate these for you, which is really quite impressive. So you've probably gone through the process of setting up intent filters and setting up all the right configurations, making sure that it's passing parameters correctly, making sure you're catching the right type, you've got the right domain. And it's really tedious. So this makes it really simple to implement this by declaring the relevant graph in your manifest. This will go between your activity that you want to have for the host activity. And then in your navigation graph, you define your deep link via app URI like this, like so. It should be noted that you can include parameters like this, and these parameters will be encoded with the same name as the arguments required for the destination. It doesn't yet support wildcards. It has to be an exact regex match, so be careful of that. So what sort of navigation styles can the navigation component introduce? So we've already got the toolbar that we're very familiar with the alternative toolbar for contextual variations. You've got beloved bottom navigation that is totally Android and not iOS. And you've got the historic navigation drawer, which would allow you to obviously have as many items as you wanted, but you should probably keep this to a minimum. So you configure these by setting up with nav controller. When you first start off with the activity, you just need a single line set up with nav controller, and you reference the layout ID for your drawer layouts or for your bottom layouts. And there are a lot of extension functions, a lot of different variations of this function that provide the implementation necessary for either being a drawer layout, either bottom layouts, or anything as necessary. So it might look something like so. Now we've got Kotlin. Let's use our lazy instantiations of these fine IDs. And you can just set it up with nav controller through the controller and the drawer like so. Like I said, there are a lot of different variations of this function for different types of behavior. So you're basically providing an app bar configuration, and then the shorthand syntax will then create an app bar configuration based upon what argument you passed it. But then you can also create your own app bar configuration. You can say, what are the top level components? What behavior should I do if I'm not handling my up listener? So, as I mentioned, top layer destinations, failure on draw layouts, fallback up listeners if you don't handle this. This is quite useful if you want to have custom behavior that's not quite covered by the library. And this will be done through the add on destination change listener. This is not a closed API. You can actually just say, I want to handle the destination changes myself. And then every time the destination changes, you'll get this callback. So if any of the app bar configurations don't quite work for you, no worries. Just add a destination change listener and handle it yourself. As mentioned, bundles are our favorite little way of encoding data. So despite having better scope operations between fragments and activities, we still have to encode parameters. This is no different from activities as it is from fragments. I want to give an honorable mention to a library we started using a long while ago from Eugenio. This is a way of using Kotlin delegates for properties on intent extras. And it worked out really nicely to actually have something straight up like this. So you have your extra define your intent options on your companion object, and you could simply just set this in an intent and then pass it along to the activity. Now this was super nice because we didn't really have much else available, and it used Kotlin delegates, which was quite nice as well. And it had a single named location for the parameter name. So you didn't have to worry about having both your calling and receiving activity having the name that needs to be serialized. But the navigation library introduces safeargs. Safeargs is a plugin that will generate an implementation, a Kotlin implementation of your encoding and decoding serialization for your activities. This is null safe, provides defaults, and you can use primitive and parsable values. You should probably also use the keep annotation to make sure if you're using with ProGuard that these classes not being collected. It'll also generate directions. So if you have a fragment like this with an action defined, it'll generate the direction main fragment directions.main view balance. And the nicest thing about this is that then if you define an argument on this fragment that needs to be provided at runtime, this generated class will then change, breaking your compile. Now, breaking your compile might be not seen as a good thing, but I would much rather break at compile time than break at runtime, because if I'm not providing this parameter and then I expect this parameter, it's not there, you're going to get problems. So let's add an argument to the balance to the fragment and see how it changes. So when we first had the main to view balance with no parameters, now we have to call it with a parameter, and it will make sure that it's done so properly. And you can decode it at the end as well with the from bundle. So this is what the class might look like. Now, generated classes are really never, ever good to look at, but they're consistent and reliable. They provide simple operations to serialize the data correctly, and they can support enums, parsables, and other primitive types. Nothing magical here, but it's reliable and it's scalable. You can convert a bundle using the from bundle companion class, companion method, and you can create it using named parameters or optional parameters as provided in your navigation graph. And your directions class, again, nothing special, but you can see what's going on here. It's using the same method of serialization. So you can indicate that you want to go from main to view balance by passing this amount, and it will pass the correct directions with the argument serialized as proper. And it's great because it's a single source of truth. By defining these arguments and parameters in your navigation graph, you don't have to worry about having them anywhere else. These classes are generated for you, and you can reference them safely and easily. And it's a single source of truth. You don't have to interpret it in other activities. It's not open to interpretation. So the nice news is that you don't have to immediately migrate from anything to use safeargs as activities. You can already create safeargs for activities and encode your existing parameters. So you can use this wonderful bundle serialization straight out of the box. The destinations are not generated for activities because you still have to handle the navigation yourself, but you can still use the benefit of having safeargs at your disposal. How would you get started with this? Apply the plugin. It's quite actually simple as that. You add the class path and you add the plugin and make sure it's the right version, and then you're good to go. So how would I migrate if I'm already using activities extensively and I wanted to then try it with a navigation component? Now, it might be difficult in some cases if you have an extensive use of activities, but you can use safeargs for activities, as I mentioned, but you have to decide on the benefits and drawbacks of doing this. So, as Ian Lake mentioned in his video as well, if you've already got an existing setup, you probably want to maybe think about leaving it. If it ain't broke, don't fix it. But if you're using new implementations, if you're creating new modules, or even if you have a greenfield project, you can then surely consider it. So how would I migrate if it was feasible to do so? So let's consider on the left, we have a list of cheeses, and on the right, the details of said cheese. I couldn't help myself. So you pretty much want to kind of move your behavior from activities to fragments. So you can then create fragments one by one and then migrate as needed. Now, you should probably already be doing something that keeps your behavior outside of your activity, whether it be through effective architectural types or using view models. So it shouldn't already be a concern. But if it is, you can start migrating things over and create fragments for each one of your activities. So instead of create new activity for your fragments as a host, it'll just be a blank container for now, then we can introduce the host later. So we want to move existing activity logic to your fragments. Start off by making sure your fragment bindings are updated in your activity. So if you're using data binding, you want to make sure that your generated binding classes are changed over, because these represent the name of the layout file, not the implementation. You want to make sure that you change your behavior from using onCreate to the onCreate view and appropriately inflate your layouts. And then you want to do any post layouts or post view behavior in onViewCreated to make sure that the view has been created correctly and then you're using it appropriately. And finally, as I mentioned earlier, you'll want to make sure that you're using the view lifecycle owner. So the view lifecycle owner has a very kind of slightly different behavior from the fragment lifecycle, and it comes into play when you're using detached fragments or headless fragments, because the lifecycle is not the same, and you can end up with some runtime exceptions. So you want to initialize the fragment in the host activity, Pretty straightforward. This is same as I showed you earlier. You just create a new fragment and you assign it to the transaction in flow, and you assign it to the support fragment manager. And if you need to pass arguments, you just pass them on for the intent extras. This is nothing new here. This is just existing fragment implementation. But then, once you've done this, you want to then create the navigation graph. Navigation graph might be quite simple, something simple. So for our two destinations, we have a cheese list fragment and a cheese details fragment. These two fragments live independently, and they're both addressable quite easily. But we'll then have to create a navigation host. So in our host activity, you just add this fragment host. You provide the named implementation for the default fragment. So this will be the nav host fragment that acts as the host. And you provide the graph, which is the cheese list graph to be created, and indicate that this is the default navigation host. This means you don't have to do any additional setup, and it will kind of take over from layout inflation. Now, after this point, our activity becomes empty because we don't need any additional behavior. This navigation is handled in the activity, in the navigation graph and the navigation controller. So we don't really need to do anything here. We can just remove the code and have a simple activity. But let's add some parameters. So if you're moving from the list activity, you'll want to provide the ID of the cheese that you want to reference. So let's add the action to move from one to the other, and let's add the argument to specify that this fragment needs to know which cheese you're providing to show details for. And then in the cheese list fragment, we want to indicate that this is the way we're moving, and this is how we're doing it. So you've got a click callback, which is just generating the direction from the generated class. So the cheese list directions.navigate to cheese details. And you pass this to the navigation controller, specifying the navigate function. You can just assume the default implementation for the cheese adapter. This is just for boilerplate. And that's your implementation. Pretty straightforward. So it's actually quite easy to kind of get going with this, and you can decide what level you want to integrate it and how deeply invested you want to go. But it's quite possible to actually use a single activity for your entire application. It's probably better to start with the individual modules and just use it where you can. But if you're starting off with a new application, for example, it's a great option. And the beauty of it is that the navigation library handles all the caveats and all the kind of complexities of fragments. So you get all the benefits of having the fragment X in library builds, but without any of the costs of all the weird and crazy stuff around it. So I often get the question about this as well, though, like how to handle activity results. Because if you're handling navigation in the navigation controller, how do I say navigate for start, navigate for a result? Now, this isn't yet supported, but activities and fragments still have the onActivity result, which you can rely upon if you're calling something outside of your navigation graph. But the thing is, you don't necessarily need to use it all the time. You can simply say in your specification in navigation graph to say, I'm navigating to this with this argument, and then I'm coming back with this argument, and you can have an argument for an individual action that will be generated appropriately. So you can still sort of use it, or you could just use a shared view model to pass data between the two fragments. There is, however, an issue asking for support for this. So this is the issue with Google at the moment. You can go up and vote for it, then hopefully it'll be implemented soon. There's also the implementation of live data events. You might be familiar with the single live data concept that would pass individual events from a view to a view model. I recommend going with the event basis because you can have more control over whether an event has been observed or not, and you can still actually retrieve the value. And you don't have to use a custom implementation for single live data. You can just use existing live data or immutable live data. There's a blog post from Jose here. Links will be at the end as well. In the slides as well. And finally, one of the other issues might be dynamic features. Now, this is a bit of a tricky one, actually, because if your navigation graph is being generated in a submodule, then how would I move that submodule above my app and then reference it via directions? We don't know yet. So this is coming soon. The team are looking into it. And it's one of the more exciting features, which I'm hoping will be part of the library soon. But it's going to require a lot of close collaboration between the guys on the dynamic features and, well, basically Ian on the navigation library. So there's a great talk from Ian as well about the single activity, why, when, and how. He goes into a lot of detail about testing and how to manage these components and how to kind of get started with it as well. Some of the similar content I've talked to you here about today, and the advantages of using this and how you could migrate to it. And that's all, folks. Thanks.